Okay, so let's start. Question number one. Power is the rate of doing work. So the average power, this means average, is the same thing as saying change in work over change in time. Work is measured in joules, time is measured in seconds. Together, joule divided by second is called watt. 1 watt is 1 joule per second. And that's average power. Yeah. And put some emphasis on average because later on you'll learn instantaneous power. Okay, so power is measured in watts, and watts is the equivalent of saying joule per second. Question number two. A woman pushes a shopping cart down a supermarket aisle which is 25 meters long. So you have the aisle is 25 meters long with a force of 12 newtons. Yeah, and you have a shopping cart, you have a woman pushing the shopping cart with a force of 12. This force has to be, horizontal because, that just makes sense. And the time it took her to reach the end of the aisle is 10 seconds. Yeah, find the power. Power, or average power, sorry, is the change in work over the change in time. Yeah. What is work? Work is just force multiplied by distance multiplied by cosine theta. Yes, over the time, which is 10 seconds. Cool. Now, what's the force? The force is 12 newtons. What's the distance? The distance is 25. And what's cosine theta? Well, the force is parallel to the direction, so the angle between them is 0, right? Cosine 0 is equivalent to 1, so that goes away. So all you have is 12 times 25 over 10, which is, let's divide by 5. This becomes a 2. This becomes a 6, so 30 watts. Question number three, instantaneous power. Instantaneous power is the power at a certain instant, I believe. Maybe common sense says that. The instantaneous power is defined as the dot product between the force and the velocity. The dot product between any two vectors is written like this: the magnitude of the vector multiplied by the magnitude of the other vector multiplied by the cosine of the angle between them. That is what a dot product means. Probably didn't take this yet. So that's the problem with the school. They teach you things later. Okay, where v is the instantaneous velocity, and the theta, I'm not sure. Theta is the angle with the horizontal. I believe. Okay. Okay, so question four. A block is being pushed along a horizontal surface. Let's say the block is a dot, yeah? With a force of 16 newtons, making an angle of 45 degrees with the horizontal. So that's 16 newtons. At some instant t1, the velocity is 12 meters per second. Find the instantaneous power. Instantaneous power, from the previous question, we saw that power, instantaneous, INS yani instantaneous, is the same thing as saying force multiplied by velocity multiplied by cosine theta. So just substitute the numbers: 16 multiplied by 12 multiplied by cosine of 45, and that will give you 135.76, I believe, something like that. So question 5, a body is thrown vertically upwards with an initial velocity of v0. At the highest point, the velocity is 0. So if you have a point here, it has a velocity of 0, and then you threw it upwards, it came here, and your final velocity is 0, right? Because it stops in mid-air for a split second, and then it falls down. Okay, what is the change in kinetic energy of the body? Change in kinetic energy, yani final kinetic energy minus initial kinetic energy, right? Your final velocity is 0, and your initial velocity is is v0. Yeah, so your change in kinetic energy is going to be 0 minus this. In other words, it's this. Now, part B, what happened to that energy? The energy from here to here, your kinetic energy, which is the magnitude of your kinetic energy, which is this magnitude, yani without the negative sign, this gets transferred to mgh. It becomes potential energy. Yeah, because here you gain the height. Here your height was 0. Now here your height is, let's say, h1, yeah, or h final. So mgh final is the same thing as half mv squared. Yeah, your kinetic energy, which is here, gets transferred to potential energy at the very top. Let's go to the next one. A constant force of 2 newtons is used to stretch a spring with a natural length to rest at an extension of 2.5 centimeters. So delta x is 2.5 centimeters, yeah? 2.5 centimeters يعني 0.025 meters, yeah? Now, what is the work done by the force? Work done by a force on a spring is half k delta x squared, yeah? Or if you want, what is your force? Your force is k delta x, right? So if you want to rewrite this, it's going to be half the force multiplied by delta x. So because this is the same thing as saying half k delta x multiplied by delta x, right? K delta x is just the force. So half f delta x, which is the same thing as doing this. Later on in the video, you're going to see this this formula pop up. Okay, so your force is 2 newtons. Your delta x is this value over here. So if you substitute them, this cancels with this. So this is the work done, joules. Okay, what happened to that energy? That energy gets stored in the spring as elastic potential energy. Okay, so question 6. A particle of mass 8 is lifted at equilibrium from a point which is at 12 meters above sea level. So here's sea level, and your particle is initially at 12 meters above sea level. It was raised to a point that is 26 meters above sea level. So it went from here to here. Okay, so from here all the way to here. Now they're asking for the change in gravitational potential energy. What is gravitational potential energy? It's called U. And U is equal to mgh. Gravitational potential energy is equal to mgh. They want the change in gravitational potential energy. This means change. They want the change in U, change in gravitational potential energy. Now, what does change mean? Change means your your final minus your initial. So your mgh final minus your mgh initial. In other words, m and g are constants. You can factor them out. So you're left with this. H final minus H initial. Now, what's H final? 26. What's H initial? 12. What's your mass? 8. And what's your G? 10. Do that on a calculator and you shall get 1120. And any type of energy is always measured in joules. Yeah, gravitational potential energy, kinetic energy, any type of energy is measured in joules. So yeah. Question number 8, change in U. We did this previously. It's going to be mgh final minus mgh initial. Factor out mg. You're left with hf minus hi. Hf minus hi means delta h. Yeah, delta means change, and change means final minus initial. So mg delta h, and this is equal to change in gravitational potential energy. Cool. Question 9 and question 6 are the exact same question, so refer back to question 6 for question 9. Okay, question number 10. A force is said to be conservative if the work it does can be stored and then released without the work being lost, yeah? Conservative, so force is said to be conservative, okay? That's the first blank. Conservative forces are functions of position. I'll explain this in a second. A force is said to be non-conservative, or if you want, dissipative, or dissipative, if the work it does is partially or fully lost. Okay, a non-conservative force is usually a function of, I believe, time. Maybe, I'm not sure. Anyways, what does a conservative force mean? Conservative force, yani, whatever action you do or whatever force acts on your body, if your object was here, let's say, and it became over here, it gained potential energy, right? It gained potential energy. Now, potential energy only depends on your position. And if you're here, your potential energy is just mgh1, let's say, mgh1, yeah? If you're over here, it's going to be mgh2, for example. And if the object were to drop from here to here, your full energy is converted from potential energy to kinetic energy. Your full energy becomes kinetic energy. Not some of it, not part of it, but the full energy becomes kinetic energy. So it's conservative because the full energy gets transferred. Now, if a part of that energy gets transferred, that's when you have a non-conservative force or non-conservative work, if you will. Okay, so question 11, state whether the forces are conservative or dissipative. A spring is stretched as long as the elastic limit is not exceeded. It's conservative because the elastic limit is not exceeded. Otherwise, it would be dissipative. A body is raised from ground with a constant velocity. Raised from ground, yani it gained mgh. Mgh is always conservative. Why? Because it's a function of position. That means it only increases or decreases according to your position, your height, yani. Yeah, if you gain height, you gain mgh. If you lose height, you lose mgh. Yeah, a horizontal force is being pushed with a rough horizontal surface. Rough horizontal surface, and you have friction. If you have friction, that means it's dissipative or non-conservative. Yeah, dissipative is non-conservative because when you have friction, you lose energy as heat between you and the floor. Okay, so question 12, the elastic potential energy in a spring, constant K, and it's compressed by an amount X is equal to. Okay, your elastic potential energy is half K delta X squared. Okay. So question 13, a 6 centimeter spring of negligible mass has a spring constant of 8 newtons per centimeter. Yeah, it's changed from centimeter to meter. So you multiply by 10 to the power of minus 2, right? This is equal to 800 newtons over meters. Cool, so K is 800. Okay, and your initial length is 6 centimeters and 0.06, and that's the initial length, L0. Now, what is the elastic potential energy stored in the spring? Elastic potential energy is like this. Okay, your K is 800. Your delta X, so let's read A, it's compressed to a length of 2 centimeters. So your final length is 0.02, and your initial length is 0.06, and you have to square all of that. Now, if you solve this, you're gonna get, let's see, you're gonna get 0.64 joules, of course, because it's a measurement of energy, elastic potential energy. So it's energy. B, it's stretched by length of 2, and it's stretched by 2, and your delta X is 2. Okay, so half K delta X. Now it's 2 centimeters, so 0.02 meters. So, and of course you have it squared, multiplied by 800. Do that on the calculator, and you should get 0.16 joules, of course. Yeah. 14. A force exerted on any part of a system by an object outside the system is called an external force. Yani, if you have two boxes and you consider this entire thing as the system, if this entire thing is a system, then let's say you had a human being pushing both forces, yeah? This force would be external because the human being is not part of the system, you know? And let's see, the second one, a force exerted by one part of the system on the other part of the system, this is called an internal force, yeah? If this entire thing is the system, then the force exerted by the small box on the big box is considered internal, you know? Question 15. Consider a bulb which hangs from a wire on a ceiling, yani from a ceiling. And you have a wire right here, and then you have the bulb. And the question says, your system is only the wire and the bulb. State whether the forces are internal or external. Okay. Weight of the bulb. What is weight? Weight is the force done by Earth on the bulb. Earth is not part of the system because your system is only the bulb and the wire. Thus, gravity, which is weight, is external because Earth is not part of the system. Okay. 2. The tension of the wire. Tension of the wire is the force done by the wire on the bulb. The wire is part of the system. That means the tension is part of the system. That means the tension must be internal. You know. And the last one, the upward pull by the ceiling on the wire. The ceiling is not part of the system. That means the ceiling is an external object, which means any force done by it is external. Okay, so question 16, a ball of mass 2 is dropped from a height of 84 meters and choose your system to be the ball alone. Calculate the work done by gravity and choose if this work is internal or external. Now, let's just calculate the work first. Work is always going to be equal to minus the change in U, if you're looking for the work done by the gravitational potential energy, by gravity, which is gravitational potential energy. Yeah, so your work is equal to minus mg h final minus h initial. Yeah, your ball was over here, it dropped and it became over here. So your final height is 0, your initial height is 84 given. Yeah, so your final height is 0. This is final, this is initial, so this is going to be 84. Your mass is 2, your g is 10, so this is 20. Yeah, now if you solve this, you would get 1680 joules. Yeah, now is this work internal or external? What is this work caused by? This work is caused by your gravity, because it's gravitational potential energy. What is gravity caused by? It's caused by the earth. Now, is earth part of the system? In the question says your system is the ball alone, so earth is not part of the system. In other words, your earth is external. If your earth is external, then any force done by earth on the ball is also external. Thus, gravity is an external force. If gravity is external, then the work done by gravity, which is gravitational potential energy, is external. So your W here is external. Okay, now part B. Using the equations for uniformly accelerated UACM, find the velocity. So we know that V final squared is equal to V initial squared plus 2A delta x using UACM. Yeah. Now your ball was over here. Take this to be your origin. Now your acceleration is downwards and your direction of motion is also downwards. Now you're moving away from the ball, and your acceleration must be negative because you're moving away from the origin. Yeah. So, and your initial velocity is 0 because the ball wasn't moving initially. So this is 0 squared plus, and your acceleration is negative because you're moving away from the origin. What's delta x? Delta x is 0 minus 84, right? So 0 minus 84 is just minus 84. This goes away, minus and minus goes away, and now you just solve. So V final is equal to the square root of 20 multiplied by 84, which is the same thing as saying 40.987. 80, blah, 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 blah. In other words, 41 if you want. Okay, now part C, hence find the change in kinetic energy of the ball. Now your ball was over here and it came over here. Here you had no kinetic energy. So your kinetic energy here is 0 because you weren't moving. And your kinetic energy is just half mv squared. If you weren't moving, your velocity is 0. But you had mgh. Yeah. And now you dropped here. Your height is 0. That means you don't have mgh, but you have velocity because you were falling. Yeah. So here mgh plus ke is going to be equal to mgh final plus ke final. Yeah, this is the conservation of energy. Sum of energy initial is equal to sum of energy final. Initially you didn't have a kinetic energy, and finally you don't have a gravitational potential energy. In other words, mgh initial is equal to ke final. Okay, so mgh is equal to half mv squared. M cancels with M. Now you want to find your, okay, never mind. Let's keep the M's. They want you to find the kinetic energy, which is just mgh. What is mgh? Mgh, well, we found it somewhere over here. Come on. Yep, right there. This is mgh, your change in kinetic energy. Okay, so question 17. A truck of mass 5 tons is traveling along a level road with a resistance of 200 newtons. So you have your friction, which is 200 newtons. Then you have your pushing force, which is unknown. Find the power developed by the engine given that the maximum speed is 50 meters per second. Now here we're going to have to assume that the velocity is constant. For all the questions where they don't tell you the velocity is constant and they look like this, just assume that the velocity is constant. If the velocity is constant, the acceleration has to be constant. Has to be 0. The acceleration is the change in velocity over change in time. Yeah. Change in velocity is v final minus v initial. Since the velocity is constant, that means v final must be equal to v initial. That means v final minus v initial is 0. So your acceleration is 0. So now let's solve the question. If your acceleration is 0, that means your instantaneous power is equal to your average power. Always. Okay, so now let's solve the question. Your power is force, velocity, cosine theta. Now, what's your velocity? Your velocity is 50. What's your theta? Well, the angle between both forces and the horizontal is 0. Yeah? Now, let's find the force. The force here means the net force, yani the sum of all forces, that is. Sorry, what am I saying? I meant to say the pushing force, yeah? So now we know that acceleration is 0, and we know that the object is moving. And if the acceleration is 0, that means we have to use Newton's first law. Big F minus small f is equivalent to 0. That means big F is equal to small f. Now in the question they used ma, which is Newton's second law. It doesn't matter because acceleration is still equal to 0. So your big force is equivalent to your friction. Your friction is 200 newtons. And now you can just substitute. That's 200. This entire thing is 10,000. Unit of measurement is watts. 10,000 is the same thing as saying 10 kilo, and then you have watts. So 10 kilowatts. Okay, so question 18. A truck of mass 7 tons is traveling along a level road with a constant resistance of 500 newtons, and the truck's engine is working at 130.2 kilowatts. Now, so the truck is moving on a flat road right now. Now, all of a sudden, the truck ascends a slope inclined at 50 degrees. Yeah. So the truck was moving here. All of a sudden, it starts climbing the incline. Now, let's draw the diagram. So 50 degrees, you have the truck, the normal force on the truck, the force pushing the truck, the friction pulling back the truck, and the weight. Now, we don't care about this weight. We only care about the weight on the x-axis, right? So what's the weight on the x-axis? It's going to be W sine theta. It's W sine 50. W sine theta, and theta is equal to 50. Yeah. So now what we're going to do now, so let's label the weight here so you don't really lose it because, yeah, so that's the weight. W sine 50. Okay, so let's read. Let's continue reading. They're telling us find the maximum speed. So we have the power. So we know that work over time is equal to the power. We can't just simply say that power is equal to F V cosine theta. We can't say that. Although in the end, you'll realize that they're the same. But for now, we can't say that because they never said find the instantaneous power. Okay, so work is equal to F d cosine theta, right? How many forces do we have? We have 1, 2, 3 forces. So we have to treat them each alone. So as you can see, we're going to assume that the velocity is constant. Okay, that means there's no acceleration. We're just going to assume that. The question doesn't says it, but you always assume it. Okay, so if there's no acceleration, that means we use Newton's first law, not Newton's second law, right? So F minus friction minus weight sine 50 is equal to 0. In other words, F is equal to friction plus sine 50, right? So now our force is this. So let's substitute friction plus weight sine 50. Now, we don't know the distance, so we're just going to call it x. Now we just need to figure out cosine theta right now. What's the angle that friction makes with the horizontal? 0 degrees. And what's the angle that the weight sine 50 makes with the horizontal? Also 0 degrees. So we multiply this by cosine 0, and we multiply this by cosine 0. Cosine 0 is equal to 1, so this goes away. And same thing with this. So this is our work. Cool. Now work over time is equal to power. But this is distance. And distance over time is the velocity. So distance over time. So distance over time is the velocity. So this goes away. We have velocity. So all we have to do now is substitute the values and solve for velocity. Friction is 500. Weight is 7 tons multiplied by 10, because 7 tons and 7,000 kilograms multiplied by sine 50. V equals to P. What's the P? P is 130.2 times 10 to the power of 3, because they said kilowatts, yeah? Now you solve for V, and you get that the velocity is equal to 2.056 something, which is, in other words, 2.41. Okay?